It's my pleasure to kick off the keynote part. We have plenty of good content here for you on stage. But first things first. It is an anniversary year, and we've heard already one part of this anniversary. It's the 10th edition of the Spring I/O conference, and that alone is quite an achievement. This is by far the largest community gathering that we have, and it's also personally I appreciate everything Sergi does here, that it's happening in Europe, that it's happening in Barcelona, that so many of you are showing up here every year. This is just awesome. Beyond that, we are celebrating a project anniversary, actually 2 of them. We have 20 years of the Spring Framework Project. The Spring Framework Project got initiated at the turn of the year to 2003. Back then, the SourceForge project got set up in February 2003. The first pre-release, Spring Framework 0.9, the first public release, came in June 2003. So all around 20 years ago. And as you may imagine, 20 years, in particular to me, feels like a long time. I've co-founded the project back then, literally when it went on SourceForge, and I've guided the release management from that 0.9 release, those 20 years ago, all the way up to the present-day releases. So there's a lot of personal history in that anniversary. And even in adding, basically, to the length of the time frame, the Spring Boot project, which we introduced way after the fact, basically was the new kid on the block way back in the meantime. The Spring Boot project is 10 years old already in terms of its initiation. The first Spring Boot general availability release came in early 2014, so it's going to have its general availability anniversary early next year. We're working hard back then to set up the Spring Framework 4.0 foundation for Spring Boot. So as you may imagine, back then a launch of a new entry point towards our entire offering in the form of Spring Boot was one of the heaviest liftings that we did in the history of Spring. So at that opportunity, I could go into more nostalgia and be very nostalgic about things. I choose not to be. I'd rather take the opportunity that we have here at this event, that the entire core framework team, the people that I work with every day as in my role as the project lead of the core Spring Framework project, they are all in attendance here. So I'd like to welcome them on stage. Guys, come up, show your faces, make yourself be seen. So these are the people that I work with on an everyday basis. We basically run everything that happens on GitHub in the Spring-Framework repository. So the shared responsibility of that GitHub repository stands right here on stage. So as you may imagine, we are using Spring I/O also as a team meeting opportunity. We don't see each other all that much. Most of us work from home pretty much every day. So we are a distributed team, but there's quite a bit of history in this lineup already. Quite a few of you have been with the Spring Framework team for a long, long time. So this is the current incarnation of the core framework team. A reminder, what we mean by core framework is actually very broad. So Spring Framework is everything from the core container, AOP framework, up to Spring MVC and Spring Web Flux, the entire foundation for the rest of the portfolio. So keep your feet up on stage for a moment. So there's one more anniversary I'd like to add, and it's a personal one. So I'll actually have my 15th wedding anniversary with my wife, Eva, in just about 2 weeks. and I'd like to use the opportunity to welcome her on stage as well. And while you're at it, take the kids with you, because I've got my entire family here. So kids, Fabian, Yasmin, Isabel, please come up on stage as well, just for a moment. So it really is an anniversary year for me in so many ways. Actually, my wife Eva, she shares a lot of the history with me. She's been around ever since the inception of the Spring Framework project, so she knows everything from the very early days when we've been two people. So, hey. So, also thanks for everything you've been doing over all those years, for all your support in this, and all the shared history. There's a lot of personal energy that went into these 20 years, as you may imagine, from everyone's side. So thanks, everyone. Thanks for being on stage. Waving to the audience. This is actually, for you, it's a great opportunity to actually see who Daddy is working for. All these good people in the community, quite a few of them actually are present here in the audience today. Otherwise, they just see me kind of staring into a laptop and doing something for someone that I try to explain to them, but never really get very far. So this is probably the best real-life incarnation we have to show to them. So thanks, everyone. And we'll get on with the show. Thanks, guys. All right. So let's move on to some announcements, pre-announcements, some stuff happening. Spring Boot 3.1, the actual general availability release of the current release train in Spring Boot, goes live today. So it looks like it's conference-driven, but it's actually not. We have a regular release cadence. These releases happen every half year based on a predictable cadence, a predictable schedule. The Spring Boot 3.1 release is simply due today. It's a coincidence. There's quite a bit of good stuff in there, in particular around test containers and the Docker Compose support. We'll hear more about Spring Boot 3.1 specifically in the final part of this keynote. For our initial purposes, I'd like to immediately move on to the next iteration that we're working on already. We're working towards the next version of the core framework. This is going to be Spring Framework 6.1. Spring Framework drops feature releases every year. So only every second Spring Boot feature release has a new framework release coming with it underneath the covers. So Spring Framework 6.1 and Spring Boot 3.2 are due in November, in exactly half a year from today. We are kicking off the milestone phase very soon now in June. So the Spring Framework 6.1 and 1 release is due in a month, and the corresponding Spring Boot 3.2 and 1 release in July, 1 month later again. Why are we focusing so much on the infrastructure themes in general? It is due to the kind of new innovation that happens at the platform level in the Java space. You may remember all of the goodness that came with Spring Framework 6.0 and Spring Boot 3, the JDK 17 baseline upgrade, the GraalVM native support, the introduction of an ahead-of-time processing offering in the Spring portfolio. All of this very infrastructure-driven, optimizing towards certain deployments on certain target infrastructure. There's actually an immediate topic waiting for us, even this year. It's JDK 21. JDK 21 will have a long-term support label attached to it because the long-term support cadence in the JDK changed from 3 years to 2 years. So JDK 17 was an LTS release, JDK 21 is already the next, and JDK 25 will be the next LTS after that. Every 2 years. So it's due in September already, which from my perspective is an important part of the baseline upgrade that we did in Spring Framework 6.0, already in preparation for JDK 21 being the next LTS release. So very soon there will be already 2 long-term support generations of Java as a choice for your Spring Framework 6, Spring Boot 3 applications to run them on. So JDK 21 has a lot of interesting stuff in it. It's actually, there's a lot of stuff going out of preview. There's a few things that see another iteration in JDK 21. It is a totally packed release in terms of JDK releases as they come today. For example, an upgrade to the collection framework isn't happening all that often. It's coming here in the form of sequence collections and updates to the language at the same time, of course, as with pattern matching for switch and the corresponding record patterns. All of this said, now there's a lot of goodness in JDK 21 in general, but the most important one is the former Project Loom. It's virtual threads, the introduction of virtual threads as a regular feature of the Java platform. So formerly called Project Loom, it is basically a new variant of a Java length thread introduced to the core platform. There's a lot of expectation around this. There's been a lot of talking about virtual threads, the potential benefits. Now comes the time when we can find out what they can actually provide for us at runtime. So now's the time to test run them. And as of September, there's an opportunity to even bring them to production environments already. From a Spring perspective, we have virtual threads as the primary focus on our side. We have them as a re-empowering of servlet stacks, of traditional Spring MVC on a servlet container with JPA, JDBC interactions. That's the classic example for potential value to be unlocked with the use of virtual threads. A different degree, a new degree of scalability that you can accomplish with a traditionally structured imperative application with Spring MVC, traditional data store interaction APIs. So that's our primary focus, but we're exploring everything virtual threads can do for any Spring-based application. This includes messaging applications. This includes the use of virtual threads as a sort of escape hatch for blocking operations in a reactive stack. So there's many things we're exploring. If you're interested in some more of the work that we concretely do there and that we concretely plan, I'll have a breakout session later today, Spring Framework 6.1, on Spring Framework 6.1 infrastructure, where I'll go into more depth there. There's another major infrastructure theme, and we'll actually hear more about that right afterwards in the keynote. It's what we're calling JVM Checkpoint Restore. It's also called Project Crack, an OpenJDK project run by Azul Systems. This stands for Coordinated Restore at a checkpoint. It's basically a pretty simple concept, not that simple in practice as everything is, but the idea is simply you are bootstrapping a regular hotspot JVM. You're introducing a checkpoint where the entire system stores its current state to disk, and for further deployments, you bootstrap from there. You basically take that stored checkpoint image and use it for immediate bootstrapping of the JVM with the state of your application at the point that you took the checkpoint, right? So this rather straightforward idea has a couple of implications, and I'll explore more of the framework co-container level implications also in my breakout session. But we'll take the opportunity to show you the higher level perspective on what Checkpoint Restore can do for you right next in the keynote. Of course, not everything is about these new JVM facilities. We are also taking the opportunity to revisit our ahead-of-time processing. We introduced the AOT concept to the Spring portfolio in Spring Framework 6.0, and we're now in the process of revisiting it in the form of what kind of applicability can AOT have beyond being the first step towards building a native executable. There may be some use of AOT with Project Crack, with Checkpoint Restore. So we're exploring the use of AOT beyond its current applicability for the Spring Framework 6.1 iteration. And as Another example, there's actually more. Of course, there's always a lot that we bring into feature releases, but there's one I'd like to highlight here as well, and that's also a form of revisiting of our data binding and validation facilities, in particular in the web stack, in Spring MVC and Spring Webflux, where there's a lot of historically grown options that can do many things for many purposes, many scenarios, and we are now trying to revisit them, to make them interact in a better way, to make them configurable in a more straightforward way in some cases, to make them consistent between various options that we have. So, for example, revisiting the validation of handler method parameters in a typical Spring Web controller. All right. So much from my side for the high-level themes. We are not only doing breakout sessions, we'll also have a Spring BOF session tomorrow, where in particular we as the core framework team are going to be around for any questions that you may have. That's, if I remember correctly, tomorrow 10 a.m. So you'll see us reappearing there for an open Q&A. And of course, we're also around in the hallway. So if you see us around, say hi. And if you have anything that you'd like to discuss, feel free to approach us. Thank you.
Please go. Guys, please give it up for Juergen! Thank you very much indeed. I get quite emotional and just about everything. And when Juergen's, I mean, it was lovely to see the Spring team. You guys are great. But when all the family Holland came on, I was just like, oh, that's beautiful. So, and I've never sort of got a bit teary during a talk about technology that I've got no understanding about, so it was a novel sensation, but that was really great. Guys, did we like what we saw in that? Oh, very good. And so now we are moving on to the next part where we're going to have Sébastien Deleuze and Alina Yurenko talk. And so I also wanted to go and see what the hive mind of Stable Diffusion thought of them. And I've kind of discovered that if you've got a sort of name which is, in this case, either German or French, it like makes you thinks you're... So anyway, this is what they thought of Sébastien Deleuze. Look at that, sort of hot but untrustworthy. And then Alina Yurenko, and because it's Stable Diffusion and it's a woman's name, it's just hot. There we go. And so let's find out about what Alina and Sébastien are up to. So put your hand together for Sébastien Deleuze.
Okay. Hi, everybody. I'm Sébastien Deleuze, and today we are talking about how to scale to zero Spring applications. So we are going to begin by why scaling to zero. If you are building the next Netflix, you probably don't care. All what you need is a bunch of JVM servers, always on, processing requests efficiently. But for other kind of workloads, you may want something more flexible that allow you to have cheaper and more sustainable hosting. For example, let's say you are building a back office for a small or middle-sized company. It's not used during the night, not used during the weekend, so what would you pay for those periods where the application is not used? Or let's say you are building a microservices-based architecture and you have some level of caching in between the two levels of microservices. The microservice at the bottom will be used mainly after startup or during data updates. So here there is room for optimization. But it's not all about scaling to zero. I think there is a lot of benefits in being able to scale up super fast. For example, that can allow you to achieve high availability without provisioning a lot of spare server that will do nothing. And basically, your application will just be a Kubernetes good citizen. So in a nutshell, the faster your cold start is, the less resources usage you have, the closer you are to pay as you use, which is the popular billing model that you have on serverless platforms. Interestingly, with Kubernetes-based platform like Knative, You don't have to use function to scale to 0. You can just use regular functions, regular applications, and that's what we are going to see today. So today we are going to see 3 ways to scale to 0 your Spring application, 3 ways to make your Spring application cheaper and have a more sustainable hosting. And to begin the first part, please welcome on stage Alina Yurenko to talk about GraalVM native images.
Thank you, Sébastien. Hi, everyone. My name is Alina. I work on GraalVM at Oracle Labs, and I'm here to talk with you about how GraalVM meets Spring Boot and how you can build more efficient application using both of them.
Thanks, Alina. So, yeah, we have been collaborating a lot with the GraalVM team. We have weekly meetings. It has been a close collaboration to improve Spring, to make it more suitable to run native images, and also improve native images to run Spring. And this year, we are introducing Spring Boot 3, which provides official support for compiling application to native executable using GraalVM. It supersedes the Spring Native experimental project I had the pleasure to lead. And basically, we provide native support at Spring Framework level. Then each portfolio project, like Spring Data, Spring Security, bring its own specific native support. And Spring Boot is the entry point with the documentation, integration with build plugins, etc.
Yep. So let's talk about GraalVM and how deploying your applications on GraalVM is different from your typical JVM deployment. So typically what you would do, you would write your application code, you will build it, package, and then you would deploy it on a machine that has some kind of JVM runtime on it. And this is really great, and this gives you portability and gives you great peak performance, but it also can come with some challenges, especially around cold startup times and resources usage. So this is the way you would typically deploy your application on a JVM, and how is it different with GraalVM and native image specifically. So if you compare this deployment to the previous one, you see 2 new steps here. And one new step here is this compilation to native executable that is done by GraalVM. And that is the step where native image takes your bytecode and compiles it ahead of time to native executable that no longer needs a JVM to run. So it's fully functional on its own, and the main idea here is to move all those expensive operations from runtime to build time so that you can optimize, analyze, and compile the application once in build time and don't have to do it every time at startup, because most applications are started way more often than they are built. So that is a new piece of the puzzle here, and another new step that you can see on this chart here is the AOT processing of your application that is done by the Spring Framework itself. And at this stage, the Spring Framework will look at your application and ahead of time optimize it and transform it in a way that is a bit more friendly towards native compilation, but also by doing this AOT processing, for example, eliminating and transforming some reflection calls, it makes your application code more efficient on its own, even when running on a JVM. So the main idea behind the native image compilation that is coming from GraalVM is to do all of that work at build time rather than at runtime. And it can give you some important benefits, so let's look at them. One such benefit is a fast startup, and it comes from the fact that your application is already compiled and it's good to go when you actually start your app from the very first milliseconds. This also gives you important benefit around startup performance, so you don't need to wait for your application to warm up, and this peak performance is available from the first milliseconds because your code is already compiled to native. But not all applications care about startup, and that's okay. So what might be even more important, I would argue, is low resources usage. Especially if you're deploying your applications to the cloud, resources, and especially memory, is something you pay for. So if you can deploy the exact same application by using just a fraction of memory, you can significantly reduce those deployment costs. And it's hard to give general numbers, but in general, you can expect around 5x, 10x memory reduction by moving to native image deployments. One more benefit is around security, and I think this is not talked about enough when people mention native image. So with native image, there is no new unknown code loading and execution at runtime, so everything needs to be known at build time, and this way it makes your application a bit more secure. And another way is that things like reflection and serialization require an explicit allow list from your side. So you also have more control over those features, and that's another angle in which native image is a bit more secure deployment model. And the last but not least, native image also helps you produce very compact images of your applications, and this way you can deploy them easier and also scale much faster. Okay, so let's say it all sounds good and you would like to build your app using Spring Boot and GraalVM, but how do you actually do it if you want to use some third-party libraries? Because you might have heard that things like reflection require some additional information provided to native image to make them work ahead of time. So how does that work, and can you actually use your libraries? The answer here is that many libraries already adopted native image as a deployment model, and many libraries already provide configuration and information for native image within those libraries themselves. But for those libraries that are not there yet, we created this centralized reachability repo where our community team members, framework teams, many users can contribute, share, and then reuse this information that is needed for native image. And it makes it really easy to use this information to use your libraries in native builds. So on our website, you can find a list of all those libraries that already work great and are tested to be working with native image. And this reachability repository is a very nice community effort where we see a lot of contributions from the community to make more libraries compatible and available in native image mode. And I also want to thank the Sprint team for their many contributions to the reachability repo and making more libraries available in native mode. And I want to share with you this quick number. So in terms of how easy it is to build applications with GraalVM and Spring Boot, those are the numbers from our community survey where we asked people last year which frameworks you are already using specifically with GraalVM. And we see that almost half of the people in our community are already using Spring Boot and GraalVM together to build applications. And I think Sébastien prepared a demo for us where he shows how Spring Boot actually works with GraalVM in practice.
Thanks. This is a regular pet clinic where we are going to add native support. So we declare the Maven native plugin from the native build tools that will automatically use the GraalVM metadata that you just mentioned in order to support the open source libraries that we are using. Then we are going to declare explicitly a few elements of our application, like this messages resource bundle that is specific to our application. Other kind of resources are automatically inferred by Spring Boot. So we are going to use this runtime ints registrar API that allow you to register ints for resources, GNI, proxies, reflection, and serialization. Here we are focusing on the resources to declare this resource bundle, and the rest will be automatically guessed by Spring Boot. So I'm specifying that. We are going to use @import runtime ints to specify this class, and it will be automatically recognized by Spring Boot. Then there is usually other kinds of metadata that you need to add for example, here this pet class, which is not visible in the public API. Typically, that happens when you are using a reflection-based serialization that is not exposed in the public API of your Spring controllers. Then we are going to use this @register reflection for binding annotation to specify those few classes where we need additional metadata. Then we run the Maven compilation with Maven-p native compile, and then that triggers the Spring ahead of time optimization and transformation, and after that, the native compilation. If we have a deeper look, Spring is automatically generating native image configuration and metadata for proxies, reflection, and resources. That way, you don't have to declare that yourself. Everything is inferred by Spring Boot. And basically, the combination of those metadata and also generation of a functional Lambda-based application context configuration, where basically the Spring IoT transformation transforms the annotation-based programming model into something that is just using lambdas that is automatically recognized by GraalVM native image. The combination of that allows us to provide a pretty nice native support out of the box where you just have to declare a few additional bits and you get native support. And the result is a native executable that you can run. It's your application, but it's starting in a few milliseconds, and it's ready to ship in, for example, a container to production. you can see this is just the regular pet clinic. Your user won't see the difference, basically. So, Alina?
Yes. And in a few weeks from now, on June 13th, we will have a next major feature release of GraalVM. So this is not public yet, but I wanted to give you a sneak peek of what is coming up in the next release. So one of the things is we will ship both JDK 17 and JDK 20 builds. We want to be able for you to use the latest Java features with GraalVM. So we are always trying to follow the latest Java release and provide builds so you can use them with GraalVM as well. And another update is that native image will be included in the GraalVM JDK itself. So if you ever before tried building applications with GraalVM native image, you might have used the command gu install native image because that was an optional component. So now it's included in the base JDK, so it's much easier for you to set it up either on your local machine or in your CI/CD pipelines. And another new feature that we are adding is build bundles. So now, in addition to that native executable, you can also produce a so-called build bundle that in the future will help you recreate the exact same build with the same parameters, environmental variables, etc. in case you need, for example, to patch and update your application, and then you want to reproduce this build. And we are also working on reducing memory requirements and improving memory requirements of the native image build process. And we are working on several developer experience improvements that will be available in this release. So June 13th, we will have a lot to share with you. That's our next major release. I hope you will follow it and will try those updates yourself. And we have 2 more sessions that are related to GraalVM. So later today, I'm speaking in the exact same room about GraalVM and Spring Boot. And also, I think that's tomorrow, right? You are speaking with Moritz about Spring Native and Spring Native.
Yeah, so your session will be more focused on GraalVM side,
right.
And our session with Moritz will be more focused on the Spring Boot side. So, yeah. Thanks, Alina. Happy to continue the collaboration between Spring and GraalVM team, and thanks a lot for coming on stage.
Thank you.
Thanks. Okay, so we have seen the first way to scale to zero with Spring with GraalVM native images, and now we are going to introduce 2 new ways to scale to zero with Spring. So the second way is to scale to zero with serverless platform like Amazon Lambda or Azure Functions. This is already possible with Spring Cloud Functions that allow basically to deploy functional interface bins like Java util functions to serverless platform. That's perfectly fine. But what if you want to deploy a web application? What if you want to take some code of an existing application, a web application, for example, and deploy it to those platforms? It requires some change in terms of programming model. So today, I'm pleased to introduce something the Spring Cloud Function has been working this last month. This is a new capability that allows to deploy existing controllers, Spring MVC, Spring Web Flux, take those endpoints and deploy them as functions on Amazon Lambda or Azure Functions. So the benefits here is that you can reuse the well-known, flexible, and powerful programming model of Spring MVC and Spring Web Flux and deploy those functions, HTTP functions basically, to those platforms to take advantage of the advantages of those serverless platforms. You can follow Oleg's talk tomorrow. You will get more in detail into that. There will be some demos, etc. So don't miss that talk. Oleg will present all the work around this new functionality. And there is a third way to scale to zero with Spring. Juergen introduced that a little time before. It's JVM checkpoint restore, also known as Project Crack. So basically, the principle is that you will deploy your Spring Boot application as usual on production. And from that, you will be able to take a checkpoint of your application, serialize the state of your JVM application on disk, and then being able to restore it with 2 important characteristics: super fast startup in a few milliseconds with the JVM, and if you have taken the checkpoint after some requests have been processed on production, you will be able to restore a fully warm-up JVM. So I think that's 2 very interesting characteristics. And Spring Framework 6.1 is going to provide first-class support for that, stopping the application context where the checkpoint is created. It will close the connection, etc., because when you take the snapshot, the checkpoint, you don't want to have open connections, open socket, etc. And when the application is restored, Spring Framework 6.1 will be able to restore in a few milliseconds the application context. We are going to see how that works concretely with the demo. So we have a typical Spring Boot web application with a controller, okay? And we are going to use Crack to demo this new capabilities. So here, I'm using Spring Framework 6.1 snapshot. You can already try it yourself. I'm going to use this Crack dependency, and here I'm using JT because Tomcat requires for now some modification that will be basically fixed a bit later. We are using a Crack version of the OpenJDK provided by Azure, and I'm building my application as usual. Until now, nothing changed. But here, we are using Java with a Crack checkpoint 2 parameter when I specify a directory where the Crack image will be stored. I'm starting my application as usual, but now things change because I'm going to create a checkpoint with this gcmd command, okay? The effect on the Spring Boot application with Spring Framework 6.1 is that my application is stopped. The Crack files are stored in a directory, and then I can restore it with Java Crack restore from with the name of the directory. And here, I'm able to restart the application context in less than 20 milliseconds with the JVM, and I think that's pretty interesting. If we have a look to this target /crack repository, you will see that I have a bunch of files, which is basically the memory dump of the running instance. It's a few hundred megabytes, so if you want to use Crack to restore your application, you need to provide also these Crack files. And I think that's interesting because we can use that to create a container image that we can restore in the cloud super fast. So here I'm showing basically a script that will use Docker to run my application as usual. We are going to use Azure JDK with Crack support in order to create a checkpoint. And then we are going to commit with Docker to create a new version of the container image with the Crack files ready to restore. The goal is to have a container image that is ready to restore in a few milliseconds. So I run my script. It's downloading the Crack version of the JDK. We are going to start the Spring Boot application, take a checkpoint of this application to create a new version of this application that is ready to restore, okay? So this is what happened here. Once I have this Docker image, I'm going to push it on Docker Hub in order to be able to deploy it on production. When that's done, I'm going to use Azure Container Apps, which is a Kubernetes-based platform that can run application shipped as container image. So here I'm going to specify my Spring Boot Crack demo with the checkpoint version, ready to restore. 1 CPU, 2 GB of RAM, so not a crazy big instance. I'm going to enable HTTP support with Ingress. And then I'm going to check on production how fast my application context can start on a pretty low-end machine. So we are going to, we deploy this container image. We are going to see the logs, and we can see that on production in a 1 CPU machine, we are able to start the application context in, let's see the figures, okay, 100 milliseconds. So this is a real Spring Boot app deployed on a 1 CPU machine on production, and we are able to restore the application context in 100 milliseconds. I think that's pretty interesting. If you want to play with this sample yourself, you can try it. There is the script to create the Docker file, etc. github.com/sdeleuze/Spring Boot Crack demo, and just try it and use it on your Kubernetes-based platform. Let's take a bit of time to have a deeper look to the figures we have. I made various measurements to measure the time from where we start the container to the point where the application is ready to process requests to compare the various options we have here. A regular Spring Boot application with the JVM will start, so from the container start to the application is ready to process requests in 7 seconds. If I'm using the ahead-of-time optimization that are also usable on the JVM, we have begun to document that a bit more. You are able to start this same application in 5 seconds. And if you are using a checkpoint restore to restore this application, exactly the same application with an additional capability to restore a fully warmed-up JVM, it's able to start in 300 milliseconds. This is 23 times faster than the regular JVM with the same runtime characteristics. So I think that's pretty interesting in terms of capabilities. Native goes faster, but I think the big point is that both JVM plus checkpoint restore and native allow you to scale to 0, allow you to have a close to instant startup. So in practice, in this graph, you see the number of instances I have depending on the workloads that allow me with cloud platform like Azure Container Apps, or if you have a Knative-based platform, or if you are using Google or Amazon similar platforms, you can basically scale your application to 0. If there is a lot of workload, you can scale up to 10 instances super fast. And when your application is not used, you just pay nothing. There is no instance running. So it's just paying what you are using concretely. Let's keep in mind that startup time is not everything. Checkpoint restore is a regular JVM, so the memory consumption will be the same than a regular JVM. Native here keep a strong advantage because it allows to use less resources. So I have created this table to give you some insight about how those two solutions compare. So both GraalVM native images and checkpoint restore JVM images allow to have instant startup with peak performance. Checkpoint restore require upfront deployment and checkpoint storage, so there is maybe more integration with your running platform, more work to do here. In terms of compatibility, checkpoint restore is better because this is a regular JVM, while on native, you have to handle the compatibility of libraries with reachability metadata. Native can allow to run on low-resource devices thanks to lower memory consumption. Compilation time is an advantage for checkpoint restore because you don't have to do this long native build. And compact packaging is more an advantage for native image. And in terms of performances, Crack is just a regular JVM, so runs super fast on warm-up, where on a native image, community edition of GraalVM is a bit slower. Enterprise edition is closer to the performance we have on the JVM. So in the end, choose how you want to scale to 0 your Spring application. You can either use GraalVM native images, you can deploy your controllers on Amazon Lambda Azure functions, or in a few months, when Spring Boot will support checkpoint restore, you will be able to restore almost instantly a running Spring Boot instance, potentially warm up. So you have the choice. Thanks a lot.
Put your hands together for Sébastien Deleuze. Thank you very, very much. That was great. There we go. And also, Alina, put your hands together for Alina there. I think I might be getting closer to understanding what a Kubernetes is. Something to do with serverless. Is serverless as obvious as it sounds, what serverless is? I'm no closer then to knowing what it is. I was like, oh, great. I've been hearing this word being used a lot. Maybe it just means there's no servers, but back to the drawing board on that one. So we have had Sébastien and Alina, and we are now passing over to Josh Long just as soon as things are plugged in. Look at this, man plugging in his laptop in a high-stress environment. Oh, look, the tension is building. Will Josh be able to do it? Oh my God, it's happening. Are we ready, Josh? It's kind of ended up in a bit of a, the roof of this place was going to come off. Are you ready, Josh? Always even. Well, it's not the impression that I was getting 30 seconds ago. Please put your hands together for Josh Long!
Woo! Hi, is this on? Yeah.
Yeah, it is.
Okay, so let me see, 10, 20, I got 15 minutes? Yeah. Okay, my friends, I'm so excited to be here. Can we get a selfie? Yeah. Okay, easy. What about the rest of you? Okay.
That's it.
Pretend like you're happy, everybody. Just, come on. Pretend like you're happy. Everybody, ready, steady. Say open source. Oh, it's so much better. Thank you, appreciate that. I appreciate that, my friends. It's very good to be here. Thank you, my friend, for making an amazing show for the community. My name is Josh Long. I work on the Spring team. I'm just so glad to be here before you today. What's wrong, friend of friends? Oh, we're not plugged in. You can't see a thing. You're wondering what he's talking about and why he's doing it. There we are. We all good? Sweet nectar. Well, almost. Almost. Computers. Is it? Oh, it's connected? Okay, so they got it. We're just waiting for this side to have it. Huh? It's not good.
Yes, we can open with only one screen.
Okay, I've only got one screen. What do you mean one screen? What? I don't understand what just happened here. I feel like I'm missing something important here. Oh. Now I know what he meant. Now I know. He's saying I can only have one screen. What I thought he said was I can only have one screen. There's a difference. It's the, let's see, I want to mirror sweet nectar. Right on. Okay, very good, my friends. So we just learned a lot about how Spring makes it just trivial to build super performant applications for machines. And in this section, I want to just talk about some of the ways that Spring makes it trivial to build super performant applications for people, right? Like as developers, there's a velocity that we've come to expect. And this is in the sort of genealogy, the history of Spring is rooted, I think, very much in making people productive, right? Rather than writing 7 interfaces just to get a method exported through an EJB, we had something better, right? Just one little bit of configuration. Rather than having to stand up a whole application server, remember those? I don't either. Rather than having to do that, we had good built-in unit testing support, right? This is all about developer experience, and that story continues today. So we're going to talk about 2 new features. We're going to focus on 2 new features in Spring Boot 3.1. But that said, my friends, there are a lot of features in 3.1. And by the way, it's coming out, as you know, it's coming out today. Today is the big day. So, you know, good stuff. There's a lot of new features, all of which I could talk about for hours and hours and hours. One that's really exciting is this new unified support in Spring Boot for trust material. Basically, you can specify something called an SSL bundle, and then in all the places where SSL is required for configuring web clients or web frameworks, embedded web servers, database connections, etc., you can just specify a pointer to this SSL bundle. Very, very, very convenient, very powerful quality of life improvement. Another big feature that how many of you have heard about the authorization server? The Spring authorization server. It's one of those wonderful stories that started because we thought, okay, we'll create this little GitHub project. We'll help people build it, but we don't really have the time to do it ourselves. And then it turned out everybody wanted us to build it. So we actually built it. It's amazing. It's out there. It's called the Spring Authorization Server. It's GA, and it has been for a minute. Now there's built-in auto-config. So it turns into just a few properties to stand up your own OAuth 2 compliant IDP within Spring Boot, completing the sort of trilogy of things that we had to slowly reintroduce into the Spring Boot ecosystem to support OAuth clients, resource servers, and now a full-blown OAuth compliant authorization server. So I love this. These are huge features in of themselves. But today, my friends, we're going to talk about stuff, like I say, that have to do with making our development cycle just that much more robust. And so obviously, we're going to start our journey, as always, by going here to start.spring.io. This is, of course, my second favorite place on the internet. Wait a minute, what is this? Something is missing here, friends. Look at that. Meet the Spring team this August at Spring 1. Yes, but I think we can agree we're already meeting the Spring team, right? Again, after Spring I.O. Okay? There, I fixed it, okay? Look at that. Very good. Very good. Okay, so we're going to go here to start.spring.io. We're going to build a new application. There's a few things to consider here, friends. Since the last time we met, they defaulted the build to Gradle. Yeah, yay. Look, it's taken me a minute to get used to it. My New Year's resolution, I had 2 New Year's resolutions. One was to lose weight, and the other one was to learn Gradle, and I'm definitely learning Gradle. It's going well. So I'm a fan. It's good stuff. The next thing we have to care about is what version of Spring Boot. Obviously, later today, hopefully, you'll be able to just click on 3.1.0 like GA. But in the meantime, snapshots it is. And then, friends, we have to choose what we want to name our thing. I'm just going to call it service, okay? I'm just going to call it service because I am great with names. I get that from my father. My dad had a little white dog, and he named it White Dog. And then 10 years later, that dog disappeared, went to like a farm upstate or something, I don't know. And then miraculously, another small white dog appeared, and my dad named it Two. Now, I don't know if it's TWO or TOO. If I could ask him, I would. But yeah, anyway, I get that from him. My mom, to this day, she tells me all the time, "You're just lucky that I named you, son." And I'm like, anyway, friends, we're going to build a new service. You know the whole thing about this, right? You have a choice about what version of Java to use. Friends, you only have 2 choices here. While it might seem like you have 4, these last 2 are just for the lulz. They're just for the memes, okay? They're just there to see who makes terrible life decisions. Don't ever click on these. Good. We're going to leave Java 17 here. We're going to add Postgres. We're going to add the web support. We're going to add Spring Data JDBC. Here we are, like this, JDBC. And we're going to add the dev tools. And we're going to add the test container support. Now, we're missing one checkbox. Hopefully, it'll be added soon enough, supporting Docker Compose. But that's easy enough to add. We'll do it the old-fashioned way, right? By writing a thing in a build file somewhere. Okay? Now, I'm satisfied with my selections. Let's go ahead and hit Enter. And we're going to open up this project in our IDE. And it doesn't all that much matter what IDE you use, so long as it's supporting the current build tool and the version of Java. Just show of hands. I'm just curious. Who's using Java 8? Don't be ashamed, much. A little bit. Okay, well, yeah, it's not great. Okay, good, friends. So, service application. Can you see that font? It's only like a football-sized stadium of font. Let me make this display, this theme. Theme. Appearances. Appearance. Don't sync with the operating system. Do the light thing. Here. Oh, is that better? Yay, okay, good. All right. Oh, so bright. I can barely see. All right, so we're going to build an application that talks to a database. Let's just get that out of the way. I'm going to use another nice feature that you get in the new, more modern versions of Java, right? I just love records. I love them so much. So I'm going to use that. I'm going to build an application that talks to a database using a record. I'm going to create a repository here. Just a regular extends CRUD repository, managing entities of type customer whose primary key is of type integer. Nothing special about that. I'm going to build a simple customer HTTP controller, okay? And this is going to be a thing that writes to the database, or reads from the database in this case, that just has, very, very stock standard stuff. I'm not even going to call it a REST controller. I'm just going to call it a controller that does HTTP. And so I'll use these old annotations instead of using REST controller. I know the difference. It's fine. This is going to be okay. Now, friends, I want to create a simple endpoint. Let's say get mapping customers. And it's going to return iterable customer, okay? And return this .repository.find all. Very good. Pretty straightforward stuff. What I want to do now is I want to have a database with which I can interact. And to that end, I'm going to install some schema files, right? Okay, so source main resources. Get rid of these directories here. Get rid of those. We're going to use schema.sql. This is a schema file that I'm going to use to create my, my table, right? When the application starts up. Here we go. ID, serial, primary key, name, varchar 255, not null, all right? Good, so there's my schema. Now the other thing I want is some data, okay? So we'll just put some data in here, data.sql. I'm just gonna put some people who are in this stage this very morning into the table. So we'll say insert into customer, name, values. We've got Sergey, of course. We've got Deshaun. We've got Juergen with the accent, very good. We got Sébastien, also accents, right? Alina, And of course, Josh. There we go, good. So there we are, we happy few, all 6 of us. Now I want to start this application up, and I want to connect it to a Postgres database. But if I do that, if I go to public static void main and just hit run, nothing's going to work, right? It's going to be very sad because I don't have a database connected. And so, at this point, in my development cycle, normally, if I'm doing any kind of serious development, I'd copy and paste this property file, and I'd create a profile called dev application-dev.properties, and there I would plug in Spring data source, username, password, and all that stuff, and have that line up with the definitions that I see in, for example, a Docker Compose file like this. This is my Docker Compose file. The password, the username, and the DB are all called BP, so I'm going to copy that desktop talk Docker Compose to my downloads service directory, right? Service, there we go. And normally I just line those things up, and I'd make sure that when I'm doing development, I have the Spring profile for dev active, but that's a little tedious. And frankly, it's hostile to the git clone and run sort of mentality. I want to just take a piece of code and get up and running with it very quickly. So in Spring Boot 3.1, we have new support for Docker Compose, okay? So you can use that as a way, it'll automatically manage the lifecycle of the Docker Compose instance for you. So what I'm going to do is I'm going to go here, and in development only scope, I'm going to add Spring Boot Docker Compose, Command-Shift-I to download the internet. Here we go. Faster, faster. Is it done? Okay, it looks like it's done. And that is basically it. That should be all I need. Let's go ahead and run it again. And you can see now, it discovered the Docker Compose file, and it's actually starting, where did it go? Here we go. It created the container, Docker Compose, Docker CLI, blah, 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 okay? So that's up and running, and I've also got DevTools. Now, DevTools is not new. You've seen this before. It's a great way to easily reload the changes to your code base after you've made some code changes. And the basic idea here, friends, the basic insight in the DevTools is we just throw away the whole application context every single time. So all the classes that we discover, we find them when the JVM starts up. We see the new classes. When new classes are compiled, we automatically incorporate those, throw away the application context, and just recreate it anew. And we can do this because, frankly, dollars to donuts, statistically, most of your restart time is just the JVM itself. So if it's already loading, recreating the Spring context is actually really fast, okay? So what I'm going to do is I'm going to go ahead and create a new endpoint here. And we're just going to call it name, iterable, customer, by name, path variable, string name. Whoop. And we'll say return this dot repository. And I'm going to let the IDE do the work here, right? Look at that, look at that. I'm just going to let the IDE do the talking. Command enter, take that, ChatGPT. Look at that, amazing, right? So I'm going to just going to recompile this code. I'm not going to rebuild it. I'm going to go to this menu, and well, actually, I'm going to rebuild it, but I can do either recompile or this, either one. Recompile works. I'm going to do that. Command Shift F9 on a Mac. Okay, so there you go. Do that, and you'll see that it's going to there's a file watcher behind the scenes, and it restarted the application in about half a second. Less than half a second. Okay, great. Well, yeah. and the nice thing is the Docker Compose instance is still there. Now, you might say, well, I want the life cycle. If I restarted the app, if I shut down the application, the process, it's actually going to shut down the Docker Compose instance. And you may not want that. You may want, for example, to manage the life cycle of that. And here you've got some properties like start only, start and stop, or none, or whatever. But on the whole, a very nice way to build software. Now, that said, this is sort of a sledgehammer, when sometimes really what you need is like a screwdriver or something more, smooth, I don't know, more particular, more specific. So what I want to do is I want a way to run a container in my test code. If only there was a project that let me do that. If only, there's something called test containers, and it's actually something that most of us are probably already using. How many of you are using the test container support in your tests already? It's great. It's been in Spring Boot for years. You basically have something called a dynamic property source, and using that dynamic property source, you have the ability to take a running container and then use it to seed the properties that then contribute to the data source or to whatever in your application. In this release, we wanted to take that support a little bit further because we're not just writing tests here. Sometimes, maybe it's not the coolest thing, but some of us like to just start up the application, make changes, and recycle, right? It's fast enough, especially with DevTools. Why not do that? So in Spring Boot 3.1, there's a new mechanism here. And what I'm going to do is I'm going to go here and I'm going to comment out the Docker Compose support. You've been good, but we no longer need you. Thank you. And we're going to go back to our code and we're going to create a new main method in the test code. So test service application. okay? And this main method is going to delegate to the actual main method, okay? So we're going to say Spring application from, and we're going to say service application. So it's in the main code, right? I'm going to call the main method, etc. And I'm going to run it with the current arguments, but I want to augment the configuration. I want to enrich the configuration that's provided to this test scoped application by providing some extra configuration related to my test containers, okay? So I'm going to define a bean here. And in order for Spring to see this, I'm going to use the with argument here. So test service application.class. There's this. And now here, I'm going to define a bean. Well, of course, I want to use a test container, so I'm going to define a bean of type PostgreSQL container. And it's going to, and by the way, this is so cool. Look at that. Okay, that's a string, friends. I just hit Control Space and it gave me images. Sorcery. Okay, good. Look at that. Watch this. Watch. Oh, take that, ChatGPT. It's amazing. Okay, so amazing. So we've got this Postgres test container there. And now the thing is, Spring doesn't know what to do with this just yet. It doesn't know that this is a thing from which it can draw credentials that we can use at development time. And so you need to mark it as such using this nice new annotation called service connection. That tells Spring that this thing is something from which we can draw a connection. But again, if you're restarting the application, it's going to start this container and shut it down each time, which is fine. But again, it's only a couple seconds, even with the Docker initialization and all that. But nonetheless, I'd like to keep this thing here across restarts, across rebuilds and DevTools, right? If I'm using DevTools, I don't want to have to restart this. So there's yet another annotation that we need here that it comes from DevTools itself, which is really, really convenient. But unfortunately, at the moment, as configured on start.spring.io, and my assumption, my hope is that this gets changed pretty soon. At the moment, this is development only, which for some reason doesn't include, I don't know, logically it should, in my mind, include tests, but okay, it doesn't. So implementation it is, right? We're making this implementation, test implementation. I'm going to reinitialize this. I'll restart my code because I've got a new dependency on the class path, right? Okay, so now we've got this, I ran the wrong class. I want to run the test class now. I stopped the main code. Now I'm going to run the test one. So it's going to do everything that the main one does, plus have this extra configuration, okay? And there you go. It's up and running. And you can see that it started up. There you go. You can see it's doing TC Postgres 15.1 Alpine, blah, blah, blah. I've got DevTools, okay? So now, what's a good example? I guess we can just go here. I've got this endpoint. Let's go to the browser to confirm as much. Localhost, customers. I don't have, the schema is causing issues, okay, if not exists, because it does exist, it's enduring, right? So Command-Shift F9, okay, let's see if that fixes our issue. Did I make it worse? Oh. Select all from customer. Oh, and the other thing I forgot to do is I forgot to tell Spring Boot to initialize the schema, because again, remember, from the perspective of Spring Boot, this is a remote database. Even though Spring Boot is starting it up, it's not embedded in the sense of H2 or HSQL or Derby or something like that. It's actually starting up the container, and then we're talking to the container over the network. So now, if I go here, I have the correct data, I have my endpoint, I have this endpoint as well, right? Great, fine. Now, let's go and maybe change something. Maybe we don't need this endpoint, so I'm just going to comment it out. Juergen would be so displeased. I'm going to delete it. Command-Shift F9, right? And of course, this is even faster, by the way. Like if you see, I haven't restarted anything. So let's see. Get rid of that, very good. I got the error, let's add this back. Get mapping, customers, name, iterable, customer, by name, right? Path variable, string, name, same thing. Return this dot repository. Okay, good. Command-Shift, F9, all right? Recycle. It's going to compile, and there we go. So we have the application up and running. We have the endpoint. It's all good. Now, friends, this makes it so we can go really, really quickly as developers. We don't have to spend time setting up. We don't have to have the enemy of good software is that wiki page with 5,000 easy steps to production or to begin development. You don't want that. Anything that has a README file saying do these 10 things before you can start writing code, it's not great. I don't want that. I do want to say this new feature, is all powered by this new indirection called connection details, okay? This is an interface that's been introduced in Spring Boot 3. We thought long and hard about that. You can see because this interface has 3 authors. This is a new bit of indirection. Basically, the auto configuration, now instead of sourcing information from property files, it sources it from implementations of connection details. And those connection details can be sourced from properties, or from Docker Compose, or from test containers, or from who knows. I mean, this lays the groundwork for something like passwordless connections in your favorite cloud vendor or whatever. All right, my friends, who learned something new? Who had fun? I'm assuming it's the same group. Thank you so much, everybody. Have a great show.